Alright. Okay. So I was working on my associate project and I needed to create a PCB, right? So I ended up coming up with a PCB eventually that I'll show here in a second. But I kind of wanted to make a video going over my thought process. That way I can look back at this when I need to make another one, because there's a couple design choices I made that I don't know if they were the right ones to call, but I did them anyway. So anyway, let's see. As you can tell, this is my simulation here. So what I ended up doing was setting up everything, like all the footprints. So I had to go through and change all the footprints. For example, if we look at this, edit the package, select from database, I selected this one. So 1300 by 700 by 250 for the dimensions, and then it's a resistor here, and that's what the footprint looks like. Those are going to fit the ones that I actually have, like, and I bought. Apologize, I've been sick. So I went through and made a footprint for the op amps, this regulator, and everything else, and then even this one here, which is the LM2596 buck converter IC. So there's that as well, which actually does look like that. So anyway, and then we have these. These are like connector things. I don't know why I'm blanking here, but basically you put wires in there to connect to the board. So if we look at the final board, it's kind of ugly, but it does everything I need it to, so I'm not too worried about it. So this is the op-amp chip. This is the IC right here for the buck converter IC. And then these are your connectors. And then these are the capacitors. This is the rectifier. That's the voltage regulator. And there's the inductor. This little guy here is the, the SS54. So there's the SS54 here. And this is a Schottky barrier rectifier diode. So there's that, a bunch of other capacitors. So this top part's pretty simple. We have a capacitor for filtering. The feedback pin goes to this resistor divider with this potentiometer to the output here. Input, output going through here. This is just like a safety precaution here. At the bottom here, we grab from our input, make a 5-volt rail. So right here is 5 volts. We feed that into the op amp. And then all of this is doing right here is getting a steady current that we can manipulate with this potentiometer to measure against here, right? So once this comes into here, there was a separate circuit. I have modified this quite a few times. So this is largely probably not even necessary, if I'm being honest. The more I look at it, I could probably find a much more simple way to do this, but we're here now, so whatever. These LEDs are going to signal when the buck converter is being used or when it's charging anything. That's what this is for. This is basically just a comparator for that. And then this is the output as well. So this will have variable voltage with a controlled variable current as well. That's the idea, at least. This R11, you can ignore that. I just put this in for the PCB board. There is no actual resistor there. Same thing with R9 here. So if we look back at that PCB that I made, that R11's here. I changed the footprint of it so it's small enough to fit here. What this is for is to separate the two circuits from top and bottom. So that gives me a spot to ground out without powering up anything over here, because I want to test the top circuit and the bottom circuit, because I can't simulate in multisim and I haven't breadboarded yet, which I will try to get around to breadboarding, but in case, I threw that on the board. I get 5 of the boards with what I ordered, so I'm not too worried about that. And then if we look at a 3D model here, wait for there we go. So it kind of looks like this. There's a little bit of wasted space up here. It's definitely not like professional by any means, but with a little bit I had to work with. Obviously I'm not using like very little resistors either. Like I'm hand soldering this, so that kind of also makes up with why it's so large, because it is like, I forget the dimensions, but I think it's like 5 inches wide, and then maybe 2 inches or an inch and a half long this way. But yeah, I mean, this is not too bad. This is the top little footprint here. If I hide the parts a little bit, or actually, let me just get rid of them. So there's that. And if we look at the bottom side here, that's that. That's fairly simple. Throw the parts back in there. And yeah, so that's going to be pretty easy to solder. I just tried to make sure that nothing was super cramped. First things I'm going to solder, though, are these 2 surface mounts, which I think these are only surface mounts I have. Yeah. So it's going to be these 5 pins, and then this guy right here, the shot key. So, and then if you look why I chose that footprint here, if we get rid of this part, it has this giant metal thing, and the actual part that I bought, the LM2596, the adjustable version, obviously, it looks exactly like that. It has like a big metal spot on the back, so I hope that works all right. And then I hope these fit the potentiometers I have, but if not, I can do some wiring and stuff off the board. These LEDs may never turn on anyway. There were some, I had like different ideas throughout the whole project. And I had to swap what parts I'm using and where I'm sourcing them so many times that like it's kind of a Frankenstein of a project. So that's kind of why it looks the way it does. But yeah, I mean, I think this isn't too bad. But yeah, it's kind of a little like project log on where I'm at with this thing, because I haven't been able to really put too much into action since I've been waiting so long for stuff to get to me and all that. So I'll probably make a video in a week here or so from here to update on whether or not it worked. So here's to hoping it works. I think it will. I think it looks all right, but I guess we'll find out one way or another.